In this video, I'm going to talk about arc length and the area of a sector. So both of these deal with some characteristics of a circle. If I'm talking about the arc length, and I have this central angle, the arc length what this means is how long is this length on the circle here. Now there's two ways that we can figure this out. One way is this with a formula, S is equal to R times theta. So theta here is this central angle, and R is the radius of the circle. So the arc length is just the radius times theta, but the key here is that theta must be measured in radians. That's the key. Okay, so if that central angle is in degrees, we have to convert it into radians. Another way to do this is to just come up with a proportion, and the proportion that I call it is part over whole. And I'll do this example in both ways. So it says a circle has a radius of 18 inches. Say that that's 18 here. Find the length of the intercepted arc if the central angle is 210 degrees. So 210 degrees is a little bit more than halfway around. Okay, so there's my angle. Let's call it theta. And that radius over here is also 18. So what we're trying to do is we're trying to find what is this arc length? How long is that? So I'll do it with this formula first. So with the formula, it's S, which stands for the arc length, is equal to the radius times theta. Remember that I need to write that angle in radians. So I need to convert 210 degrees into radians. I'm going to multiply by pi over 180. I get 210 pi over 180. I can divide those both by 10. And then by 3, so that's 7 pi over 6. So that's the theta that I'm going to use. So S is equal to 18 times 7 pi over 6, and I get 21 pi. And the unit here is inches. If I want to write that as a decimal, that's approximately 65.97 inches here. Okay, so that's one way we can find this arc length, and that's using that formula. The second way is to do make a proportion with this idea of partial part over the whole. So what we mean here is the entire way around the circle. If I measure that angle, it's 360 degrees. But the angle that we're talking about is just a part of that 360 degrees, and that is 210. Then I'm going to come up with that same ratio, but now it's going to be with the length around the circle. So the partial length around the circle is that arc that I'm interested in. Let's call it S. And then the whole way around the circle, we call that the circumference, and the circumference is equal to 2 pi r. So 2 times pi times the radius. All right, so this is 2 times pi times 18. And then I'm just going to solve this for S. So the benefit of doing it, finding the arc length in this way with a proportion, is that I don't need to convert anything into radians. And this method also works for the next examples when we're trying to find the area of a sector. So if you can remember this proportion method, it's only one way to do both types of problems. All right, so solving this, I'm going to simplify a little. So S, in the denominator I have 2 times 18 times pi, so 36 pi. And then that fraction over there, I can reduce that to 21 over 36. I can divide by 10, and then divide both of those by 3. I get, 7 over 12. And then I just cross multiply and divide. So 36 times 7. I don't know what that is off the top of my head. Let's see if I have a calculator. Actually, I'll just do that over here. 36 times 7. That's 21, 25, 252 over 12. Pi is equal to s. And then I can reduce that. I can reduce those both by 12. So I come up with 21 pi is equal to s. Or same thing, 65.97 inches. Okay, so I get the same answer regardless of how I do this. And one thing we would say is this value, those are exact values. These are approximate values. So there's times where we're interested in the exact value, in which case we would say 21 pi inches. If we want an approximate value, maybe rounded to the nearest tenth, we would say that 65.97. Okay, and then the other thing I'm going to go over in this video is how to find the area of a sector. And what that means is, let's say I have a circle and I have this angle. The area, or this shaded region is called a sector. So what I want to do is I want to find the area of that. It's like a slice of pie or a piece of pizza. How big is that area? Now again, I can use a formula. So I'm going to say AS is equal to R squared times theta divided by 2. And just like before, I have R, and then that central angle is theta. Or I could do the part over whole proportion again. Okay, so how many square inches of pizza have you eaten if you ate a sector of an 18-inch diameter pizza whose edges form a central angle of 30 degrees? Okay, so I have, say that that's 30 degrees. And it says the diameter is 18 inches. If the diameter is 18 inches, that means the radius is half of that. So the radius is 9 here. Okay, so I'm using the formula. Let's use that first idea. The radius is 9, so 9 squared times that central angle, 30 degrees. Should have written this, but theta must be in radians. So I need to convert 30 degrees into radians. So 30 degrees times pi over 180. Divide, cross cancel by 30. I get 1 over 6. So that's pi over 6 is my central angle in radians. And then divide by 2. So this is 81. 9 squared is 81 times pi over 6 divided by 2. A little fraction lesson for you. When I divide a fraction times or divide by something, that's the same as multiplying by the reciprocal. So 1 over 2. So I get 81 pi over 12. And that reduces to, I can divide those both by 3. That reduces to 27 pi over 4. And our unit is inches here. Okay, and I trust that you can type that into your calculator to get an approximate value. So 27 pi over 4 inches. Now if I do this with the part over whole method, now again, the partial angle that I'm talking about in this circle is 30 degrees. The entire angle all the way around the circle is 360. The partial area, that's the area of the sector that I'm looking for. And then the whole area of a circle, where can I write that? I'll write it up here, is equal to pi r squared. So I have the partial area of the circle is the sector that I'm looking for, and then the entire area is pi r is 9 squared. So I just need to solve this for that AS up here. So before I do anything, I'm going to simplify a little. 30 over 360 is the same as 1/12. The denominator 9 squared, so 81 pi. And then just cross multiply, I get 81 pi over 12. And that's the area of the sector. And again, I can reduce this to 27 pi over 4 inches. Oh, This should be inches squared. And that's the area of the sector.